All right, welcome back to the third installment in my multi-cloud network architecture series. In this episode, we're going to talk about the fictitious company called Dana Systems that we're going to use throughout the entire series. And in this parallel universe, me, Dana, I own a company. I'm the CEO of this big company called Dana Systems. And I don't know what we do. Let's just say that we were some legacy company that had a bunch of on-prem data centers, and then we came out with an app, some iOS app that was killing it. Let's say it's a dating app. Dating apps are huge right now, right? So we came up with this dating app and people were swiping left and right on their matches and then people were having fun, right? This app is killing it in the industry. And that meant that we had to scale it out quickly. We had to make sure that the app was working properly and there was the best experience for our customers. And so what we realized is that having our workloads, specific workloads in specific clouds, work better for our end users. And so we might have had our databases in AWS and our front end in Azure, and then I don't know, our compute, some sort of analytics in Google, right? So we have our workloads spread across these clouds. And because the network architects of Data Systems didn't have a ton of experience with cloud because they were on-prem guys, they just started throwing things up in the cloud and getting VPN tunnels moving and up and running. And we had some native peerings there, and they're growing so fast that this is not becoming very scalable. It's becoming getting out of hand. And so Dana Systems, so Dana, the CEO, me, I was like, listen, we got to figure this out. So I don't know if I did it myself or hired somebody else to do it, but basically I put these five requirements in place. Number one, we need to have AWS, Azure, and GCP workloads connected to each other. And need to be connected to each other using the best architecture and the best latency, and so basically the lowest latency and the best throughput. We have two regions in AWS, we have one in Azure and one in GCP. And because the uptime is really important for our customers so that they can make and get their matches on their dating app, high availability is extremely important. So there needs to be high availability everywhere. We also need encrypted transport because we are processing credit card data, or there's some personal data on these dating apps that are going back and forth. So it needs to be encrypted end to end. And then in some instances, we needed the workloads in Azure to be connected natively to the transit network. And so what do you guys think we're going to work on here? We're going to be building a global encrypted network, basically an end-to-end encrypted global transport environment that's fully meshed so that all these workloads can talk to each other. And then later on, we're going to implement in a different episode on-prem connectivity, partner connectivity, SD-WAN connectivity, all these different things into that multi-cloud network architecture. So let me just take a second to show you what I want the end state to look like for this video. All right, here it is. This is the end state architecture we want to get to by the end of this video. As you can see on the top left, we have the Aviatrix controller. It's sitting in a shared services VPC. I've already deployed that. I've already configured it. It's got all the accounts and all the clouds already onboarded. Don't need to show that in a video because it's super simple. You can go through our docs.aviatrix.com, follow the guide, follow the cloud formation template, and you can spin this up in less than 30 minutes. It's super simple. We don't need to waste time on that. But that AVH controller is going to allow us to enable this centralized control and management plane. Now, further down, you can see I have really four environments. I have two regions in AWS and one VPC in each for now. We're going to add more later in different use cases and make it more complex and fun down the line. And then we have a single region in Azure with two VNets, and then we have a single region in GCP with a VPC. All right. Now, what we need to do is get all these connected to each other. Currently, they're connected to each other through a mix of native peerings and full mesh native peerings, as well as IPsec tunnels, and it's all crazy. It's all manual and hard to manage, and hard to deal with routing and whatnot. And so this is just the beginning. It's going to get a lot more complex. So we need to figure out a way to build this global transport architecture and also enable a common distributed data plane. So that's what we're going to do together today. We're going to build out these edge VPCs and make them into transit networks and have them build a full mesh of connectivity between each other. Okay. Now, by the end, you're going to see that the meshing looks like this. Each transit gateway, or let's call it a transit service node, whatever you want to call it, is going to build a mesh of tunnels to each other, and there'll be equal cost multipath routing enabled, so you can get high throughput. It's going to be built over the lowest latency links. You're going to have great performance. It's also going to be encrypted end to end. Everything in here is going to be encrypted end to end. One thing to note is that, remember, part of the requirements was that one of the VPCs, or I'm sorry, some of the VNets in Azure need to be connected natively, okay? So just be aware of that. That's the only exception to encryption. So it's not going to be encrypted from the VNet to that edge VNet here. It'll only be encrypted if you have a gateway or a service node, an Aviatrix service node in the VNet itself. But that's one of the requirements, so we're going to be able to meet it with our solution. So let's get started. All right, so this is a fresh controller with nothing really configured in it. All I have done is brought in my AWS accounts, my Azure subscriptions, and my Google accounts. And so they're already pre-onboarded, so I don't have to worry about that. So what I haven't done yet I haven't even created those VPCs I showed you in the workloads. I know I said they existed, but honestly, this is all fictitious. So let's just go create them real quickly. It isn't that hard. We can actually use the useful tools section to create the VPC. Not too difficult. So let's go add some new ones. So let's say in AWS, we have, let's call this US West 1, and I'll just call US West workloads. Okay, US West workloads. And let's go pick US West here. Let's just do US West 1, it should be fine. And give it a CIDR of 10 dot, I don't know, 1.0.0/16, since it's the first one. That should be pretty easy, right? So 10.1.0.0/16. And we don't need this to be a transit VPC yet, so let's just uncheck that. This is just a workload VPC where we're going to put some workloads. So let's hit create. It's going to take a second. I'm going to pause the video and come back when it's done. Oh, it's already done. Never mind. That's how quick we are. All right, so let's do it again. And then we're going to do an east workloads, east. And we'll put that in Virginia, that's fine. We'll make him 10.2.0.0/16, and same thing, hit create. But we're gonna do the same thing now for Azure and GCP. Those ones might take a little bit longer, I can't recall, but we'll try. So let's create a new one. Let's do this in Azure. And we're going to call that, let's call it Azure workloads. Let's Azure, because we're gonna have a native one too. Let's call it Azure native workloads. And just leave it Central US, it doesn't matter. I'll make that 10.3.0.0/16, hit create. All right, that's done. Let's do it again now, because we're going to create a non-native workload VPC or VNet. So we're going to call that one just Azure workloads. That's without the native section. Okay, we gotta select there. All right, make that 10.4. Create. Okay, let's move on to GCP. Same process. It's going to be GCP is a little bit different. So you click the GCP cloud type, and we'll give it a name of GCP workloads. Now this one I think is specific. You can't have dashes in uppercase or something like that. So I'll just put GCP workloads in lowercase without anything in the way. We're going to add a row. Let's call this workload. And then let's change it from Asia. I don't want to use Asia. Let's do Central, because all my workloads are in the US. And then we're going to make this 10.5.0.0/16. A little bit of a different process. Hit create. All right, we're done. So that was building the workload VPCs and VNets, but we haven't built the transit VPCs and VNets. So let's go back and build the transit environments for each of these cloud regions. So let's start with AWS. We have two of them, remember? So let's call this one, let's call it AWS Transit, or let's call it AWS West Transit. And let's put it in the West, let's just put it in California. And we're going to give them a new CIDR, right? It's got to be different. So let's start with the hundreds now, 10.100.0/16. And we got to make sure we select Aviatrix Transit VPC. That builds it out correctly with the right subnets, the right public and private subnets. And in the back end, we know how to build it out so that it works as a transit VPC from a subnetting and networking perspective. So let's hit create. Make sure it's right. AWS West Transit. Yep, it's in the West. Right. Let's hit create. Let's do that. And we'll do the same thing for the East. Perfect. Hit add new. Let's do the same thing. Let's call this one AWS East Transit, keep it in the East, and we'll do 101.0.0/16. Keep that check mark box there, hit create. Now we got to move on to Azure because we also need a transit environment in Azure. So let's go pick Azure, and we're going to call this Azure Transit, and Central US is fine. Let's start with 200 over here. Actually, you know what? It won't make sense because Google can't use 300 because there is no 300. So let's do 200. I'm doing this on the fly, guys. Give me a break. All right, 10.200.0.0/16. So hit create. Should be okay. Subnetting doesn't matter, right? Okay, that's done. Let's do the same thing for GCP now. And so we're just going to do GCP transit. And remember, this environment requires a little different. So let's delete that and create a new subnet. And we'll call this transit. I don't want east, no. I want central 1. I didn't spell transit right. English is my native language and I can't type. Okay, 10 dot, let's say 250.0.0/16. Really doesn't matter because the transit networking, you're not going to play with that very much anyways. And we're done. So in the end, what do we have? We have all our workload VPCs and VNets, and we have all our transit VPCs and VNets. Now that we have that built out, we can start to throw instances and workloads in those workload VPCs and VNets, and then we can start to build out the transit networking using our workflow. Now, I'll build out all the instances in the background. You guys don't have to see me do that because everybody knows how to build out instances and throw instances into VPCs and VNets. I'll do that. Don't worry about it. What I'm going to show you is the connectivity. So give me a second to build out that in the background, and I'll come back in a moment. And just like that, I've created all of the instances for my targets for testing connectivity. So I have a bunch of VMs and all those different VPCs and VNets that we created. So the first step to building this global transit network is to click Transit Network, and we're going to go to the Setup section. And here we're going to run through the workflow, and this allows us to easily spin up these different environments, these different transit environments, and provides guardrails so you don't make mistakes as you're building it out. So first thing first here, let's build them out in AWS. So let's call this one the West Transit. West Transit. All right, and we're going to select California because that's where I have my VPC. And I'm going to select the VPC I made called AWS West Transit. Remember, we made that together earlier. And then I have to pick a subnet. Now, this needs to be a public subnet, and usually you want to follow the naming schema. So we've already called this one AWS West Transit Public Gateway and Firewall Management US West. So that's where you're going to put it, right? The gateway. So you select that one. You wouldn't put it in this ingress one. It doesn't say gateway there. So you select gateway. Okay. And we're just going to use T2 micro for now. Actually, you know what? Let's just bump this up. Let's do a C5 X large. That should be okay. Let's get some power. All right, so yes, we're going to leave this allocating a new EIP. You don't have to change that. So it's the elastic IP that we'll get configured. And you know, everything else can be left pretty much by default. So we also have active mesh, and we can also enable insane mode encryption. Let's just leave that for now, leave the default. So just allocating EIP and active mesh. Insane mode encryption is super high encryption throughput, and it basically is creating a bunch of tunnels and equal cost multipathing across all those tunnels. But let's just leave it unchecked for now. We can come back later on in another video and play with that. So active mesh is important. We do want to have active mesh so that you can have active connections between all the different transits. Okay, so everything else is okay. We'll come back and mess with this stuff later. So that's all you really need. So let's hit create. What you're going to see here in this output is that you'll actually see what Aviatrix is doing in the background to spin up this transit network. So it connected to AWS. It's making sure my licensing is good, which it is because this is my demo lab. And then it's going to start to spin up the gateways. Okay, it's done. So that built out the first transit gateway in that particular AWS region. So next thing, remember that we had this requirement that an HA needs to be enabled. So it's as simple as going in here, selecting the alternate public subnet. So let's just do this one, for example, this one should be fine. And then clicking enable. That's it. That's all you have to do, and it spins it up. Spins up the instance, connects the IPsec tunnel, does all the configuration, everything for you. This has got to be 20, 30 API calls in the background, right? Or I don't know, a lot of clicks and a lot of maneuvering around the cloud front end to do this all on your own. So this is pretty amazing that we can do it all for you with just a single click, a couple drop downs and a single click. Imagine how much time you save. And if you need to do this often, spin them up and spin them down, then you would leverage Terraform, the scripting architecture, to make this repeatable. And that one's done as well. We're going to skip the rest of these steps because we're not doing that in this lab. These steps are like connecting to on-prem via a V2W, an external device, or one of our on-prem appliances called the Cloud N. Right? But what we want to do is we want to go do the same thing now for the East. So let's do the same thing for the East. Go to, I think we did, what did we do, East Virginia, I think? There it is, AWS East Transit, it already popped it up. Pick the public subnet. This one's already fine, this is okay. C5X large is okay, everything else is good. Hit create. And that one's done. Continue on, and we will make that one HA as well. Select East, we select the alternate subnet. Let's do this one, enable. The reason why we have these different subnets is because they're in different availability zones. So we want to make sure we spin these up in a fashion where they're HA across availability zones. Okay, done. So we've built out HA transits in the west and the east regions of AWS. Let's go do this in Azure now. Same process. This is the best thing about it. You don't have to worry about the underlying constructs and how to configure them correctly. You just follow our workflow and we'll figure it out for you on the back end. Okay, so this is all good. We're going to select, I think we called it Azure Transit. There it is. So let's just pick this subnet public and keep active mesh enabled and hit create. And that one's done. So let's also make that HA. Same situation here. Select the transit called Azure Transit and select an alternate subnet. Let's just pick, and it's done. Last but not least, well, I guess it depends on who you ask, GCP. So let's go build a transit in GCP. Just do GCP transit. And I think I call it, yep, GCP transit, same name. That should be fine. This is okay. We'll leave that alone, and just hit create. Should be that easy. And it's done. Let's go enable HA in that environment as well. We could put that in a different, we should put it in a different one. I think I put that guy in, yes, do a central C zone. Let's put it in A. It should work. All right, we're finally done building all the transits successfully. The next step is to connect all these transits together. So let's do that. So let's take a look at what we built. If we click the list section underneath transit network, you can see under the transit gateways subsection, you have all of the transit gateways that we built out, including the HA gateways that were automatically added when we enabled HA. So here we have the Azure Transit with the Azure Transit HA gateway, and the GCP Transit with the GCP Transit HA gateway, and so on. You can see their VPC CIDR. You can then see what HA mode is enabled, and I enabled active mesh on all of them. Active mesh, like I mentioned before, is that crisscross of tunnels that get built between them all, and enables ECMP so that all tunnels are active, and you can get higher throughput and better failover and resiliency. Now you can click any one of these transits and do show details to see more information about them. You can see the routing table. We're going to go more in detail there when we do troubleshooting and testing, but you can say, for example, I wonder what their gateway routing table shows. You can click that and see the destination, the next hop, the egress interface, and whatnot. So all that stuff is from here. You get all that diag information from this screen. But what we need to do now is connect all these transit networks together. And we can do that under the transit network transit peering section. Very straightforward. We're going to build these high throughput active mesh transits or transit IPsec tunnels between them all. It's super simple. So let's start with the west transit. I want to connect the west transit to the east transit. This is AWS to AWS. Okay, so we're gonna hit OK. And you can go in here, you can add things like, we can go through this at another time, but you can exclude certain CIDRs. Let's say you don't want certain CIDRs to make it across and to have the controller propagate those routes across these transit environments. You can do that as well. But for now, we're just going to allow everything. So we're going to do west to east. There we go, success. And of course, that does east to west as well for you, the opposite direction. So let's do Azure to west. Oops, Azure to west. So Azure Transit is going to connect to the west, AWS West Transit environment, and then we'll do Azure to east as well, because I kind of want a full mesh here. We can build this nice full mesh global backbone, high throughput, fully encrypted global backbone. We might as well have them all connected to each other. So add a new one, go back to Azure Transit, and Azure is going to talk to the east now. Hit OK. Great. And then we're going to do that again. And this time, let's connect GCP to the west and the east as well. Same process. Look how easy this is. Imagine having to do this on your own, having to go in there and configure this manually. It's a pain. You have to have a lot of windows open. You have to figure out a lot of the IPsec configuration and all that, which is kind of a pain. So let's go here to GCP. Let's connect to the east as well. I think I didn't do that yet, so let's do that one. Perfect. And let's connect GCP to Azure, which we haven't done yet. Perfect. I think we have everything, right? So Azure connecting to east, Azure connecting to west, west connecting to east, east connecting to west, GCP connecting to Azure and east west. I think that should be pretty much all of them, right? Yeah, I think that's all of them. So let's refresh this, and all of these should come up here after a period of time. And there we have it. They're all up. Look how incredible this is. We just built a fully meshed global backbone across 3 different cloud service providers in multiple regions, and they're all able to talk to each other, and they all have high throughput encrypted transports connected to each other now. And we did that I think that only took us 5 minutes or something. That was really, really straightforward. Now, what you're missing, and what I'm not able to show you right now, what I can show you later on, is that we're also going to control all the route propagation end to end, from VPC to transit to another transit into another VPC or into a VNet. We're controlling all that routing propagation. You don't have to do any of it manually, whereas you would have to do that on your own if you didn't leverage an Aviatrix controller solution. And so the next step here is to now connect all our VPCs and VNets to the appropriate transits. So let's get doing that now. So to connect the VPCs and the VNets to the appropriate transit networks, we go back to the setup section under transit network, and we scroll down to the workflow step number 4. There it is, spoke gateway functions. Very straightforward. All we're going to do is go into the right environment, spin up a gateway and an additional HA gateway, the exact same way we did with the transit gateways, and then specify which transit network they're supposed to connect to. So let's do 1 or 2 of them, and then I'll skip the rest because, I'll do them in the back end, but it's just a straightforward same thing over and over again. There's no point in showing that. So let's do this. So launch a spoke gateway. So let's go under AWS. We'll call this, let's call it east. Let's do west. West workload VPC. And then we're going to go under our California. We should be able to find it. It should pop up there. There's my shared services, but we want to use this US West workloads. There it is. Pick that guy. Remember, we're going to pick a public subnet to throw the gateway in. Gateways always have to go into public subnets. So it doesn't matter which one. Just pick that one there. And we're going to pick CX, same thing, CX5. Let's just do extra large. Everything else you can pretty much leave as default. So let's hit create. All right, that's done. Let's build the HA gateway in the spoke VPC as well. So same thing, let's select, I think we built that one in, where did we build it? In West 1C. Let's build this one in 1A. Enable. All right, that's done as well. So we're finished setting up the spoke gateways in the spoke VPC and VNets, and we also enabled HA in those spoke VPC and VNets, which means that there's a second gateway that's brought up and and peered together with the original gateway, and you get active and all that stuff. What we're going to do now is we have to connect those spoke gateways to the appropriate transit VPC that we created for that environment. So in Azure, we created a Azure transit environment. So we're going to connect the Azure workload VNet with where the spoke is sitting into the Azure transit network. So let's hit attach. All right, it's done. And then we do the same thing for GCP. Select the GCP transit. So the GCP workload is selected and the GCP transit is selected. Hit attach. All right, that was quick. And then we do the same thing for the two workloads in AWS. So the west workload goes to the west transit. That was quick. All right, and the only one left is east. Let's do that. Awesome. All done successfully. Now, remember we had that one native Azure environment that we needed to connect to the Azure Transit Network. That's the Azure Workload VPC where we didn't set up a Aviatrix gateway. Sometimes you might want to connect a non-encrypted spoke to your Aviatrix transit environment in Azure, and so that's called an Azure native peering. So we could do that here in 6B. So it's pretty straightforward. You go and find the native one. There it is, native Azure native workload, the one I created earlier. And you make sure it's going to be connected to the Azure Transit. Everything else is good. Hit attach. And we're done. At this point, we should have end-to-end encrypted connectivity throughout all the workloads, all the transits, all the cloud service providers. And it was done so simply. So let's take a look at some of the connectivity now. What we're going to do is run some ping tests end to end, and I'll just set up. I'll just use the workload that I have sitting in the West Transit in AWS, and ping all the other workloads I have across the multi-cloud network. And if I did everything right, it should work perfectly. So let's go take a look at that now. Okay, so here we are in the AWS West region, and I have this West workload. It's just a Linux box sitting in the West VPC, the West Workload VPC, and that's connected to the West Transit. So I'll use it as a central point of testing. I'll just do a bunch of pings from this box. And so I have workloads, other Linux boxes sitting all across the multi-cloud network in Azure, both in the native VNet as well as the Aviatrix connected VNet. I also have the same thing set up in GCP. So I'll build a test across the entire MCNA. So let's bring this up. The quickest way to do this is to connect to it via this EC2 instance connect, so I don't have to deal with SSH for now. Should be get access to it here. Yeah, there we go. Okay, great. So what I'm going to do is grab the IPs, because I don't remember them off the top of my head. So if I go over to the Virginia region, I should see my private IP over here of the East workload. And that's the one that's connected to the East transit. So 10.2.207.213. So let's ping that. 10.2.207.213 was it? Yeah, my memory's not that bad. Okay, great. So you can see I am able to ping that, and you can see the latency. So you definitely know it's going across region because the latency is relatively high. Okay, great. So that connectivity worked. That was from West region to East region through the Aviatrix transit environment, okay, the global transit. Now I'm going to test the same thing, but I'm going to go and hit the Azure environment, both VPCs. So let's first hit the native, or VNets, I should call them. Let's first hit the native workload in the native VNet. And so the IP of that one right here, 10.3.04. Okay, let's grab that, ping. My copy and paste doesn't work. 10.3.04. Okay. Bam. Ooh, look at that. The latency from the West region in AWS to Azure is lower than it is between AWS regions. Probably because this is closer, less hops away, I'm imagining. This is a central region, I think. All right. Yeah, central US. So it's not so far away. All right. Let's now test the non-native workload. So let's go back over here. And that's where's that guy? Right here. So his IP is 10.4.0.4. Ping 10.4.0.4. Bam. Same region, central region. So that's why the latency is the same. Very nice, huh? Look how easy this is. All right, now let's go and check the connectivity to GCP. So GCP 10.502. That's the GCP instance. I just called it GCP instance, but it's a Linux instance, also sitting in Central, so latency should be pretty similar. There we go. Actually, it's lower. GCP has better connectivity. Good job, Google. So what I've just proven here is how easy it is to orchestrate using the Aviatrix platform a global transit backbone between all your CSPs across all regions. This is just the beginning. I've shown you only a little bit of what this product can do. This is the beginning of this whole multi-cloud network architecture series. Now, what I do want to show you is what we've been focused on when it comes to the multi-cloud network reference architecture. So let's jump to that reference architecture and look at it one more time, just so we're all on the same page as to what we just built out. So what we focused on in this episode was the common global transit layer right there in the middle in beige, I guess that color is. And we built out those transit environments, right? We built one in AWS, actually we built two in AWS, one in Azure and one in GCP. In the next video, we'll also have to add connectivity from that transit layer down to on-prem and into branches. And so we'll be focusing on the cloud access layer side of things. So now that we've deployed all of this, when we go back to the dashboard, we're able to see from a high level, what have we deployed across our MCNA? Look, we have one AWS account, one Azure account, one Google account. We have 8 AWS gateways, 4 Azure gateways, 4 Google gateways, and then we have 8 encrypted spokes, 1 ARM peering, that's that native peering, and 6 transit peerings. You can click any one of these and it'll take you directly to the section of the UI where you can get more information and do troubleshooting and diagnostics of these different components of the MCNA. So let's say, for example, we go to 6 transit peerings, it takes us to the transit page, and then we can start to get information about peering details. We can edit the peering itself. Let's see what happens when you click that. Can edit the peering, we can kill it or create a new one, or edit the CIDRs that are being announced back and forth. So this is pretty cool. So go back to the dashboard here. Same thing for the spoke section. We click that. It takes us to the gateway page. And from the gateway page, we can look at any one of the gateways and click diagnostics. We can edit the gateway features, turn features on and off on those gateways, whatever you want to do now that they're deployed. Also, if we go back to the list section of the transit network workflow, we have a nice split screen of transit gateways versus spoke gateways and information about them. And from here, you can also show details and do diagnostics. All right, let's go back to the dashboard. I want to show you this topology. Remember earlier in my previous video where I talked about I actually went through a walkthrough and there was nothing showing up here? That's because we hadn't deployed anything. But now that we've deployed something, we can start to zoom in on this environment that we've built out. And you can see all of the peerings that we've built out, all the connectivity that we've built out from AWS to Azure to GCP and back to AWS, right? And you can also filter that and just show the AWS transit architecture as well. So how is this particular transit node connected to the rest of the environment? Well, you can see this in a nice little map. And you can play with this. You can move these little guys around and build how you want and save that topology if that's something you're interested in doing. But yeah, this is really nice way to visualize the connectivity model that you've built out for your MCNA. And that's it for this episode. I appreciate you guys staying with me throughout the whole thing. I'm sure you learned a lot. I want you to go and play with this and try it out on your own. It's super simple to spin all this up and play with your own use cases. And in the next set of videos, we're going to play with building on-prem connectivity. We'll be talking about inserting firewalls and all sorts of things. So subscribe and share this series with others so we can all join in. And I'm really looking forward to you guys' comments on LinkedIn and on YouTube. And anything you want me to show, let me know and I'll show it to you guys. Until next time, see you later.